So an quadratic function is an equation that has a squared in it. And so we've actually been working with quadratic functions all last chapter, right? Because we had x squares, we had b squares, we had q squares, we had all those squares. So as long as it has a squared in it, then it's called quadratic. So a parabola is, if I were to graph something that has a squared in it, it would look like a parabola. So a parabola is a U-shaped graph. So it either looks like a U, or it looks like an upside down U, or it looks like a sideways U, or a backward sideways U. But for this year, we're really just learning about the first two, the U and the upside down U. Okay, the two sideways ones, you'll learn it in Algebra 2, but we're just starting with the basics. Okay, so this chapter is all about graphing these parabolas, graphing these U's. Okay, so there's a lot of terms you need to know about a parabola, like what each thing is called. So the first thing is called the vertex. So the vertex is like when you have like a shape at your corner, right? Well, you don't really have a corner here. So the vertex would be the highest or lowest point on the graph. So it's the highest or the lowest point on the graph. Bless you. So do you see how, like, for these two pictures, here is the vertex because it's the lowest point on the graph. Here's the vertex because it's the highest point on the graph. These would be called your vertexes because they're the highest and the lowest points on your graph. There's another word you're going to learn, and we're going to be using a lot this chapter, and it's called the axis of symmetry, which we really just call AOS, just so you don't have to say it. You don't have to spell it out. We just say AOS, axis of symmetry, AOS. So the axis of symmetry is basically like, think of like the wings of a butterfly, right? They're perfectly symmetrical. When you fold on this imaginary line, that would be your axis of symmetry. So do you see, like, for this one, if I were to fold on this imaginary line, then the left side would match up with the right side. If I were to fold on this imaginary line, the left side would match up with the right side. So your axis of symmetry is always some imaginary line where if you fold your parabola in half, it would be perfectly symmetrical on both sides. Okay, so for example, let's just draw a picture like this. And then draw your parabola off to the left. So do you see, like, for this one, your axis of symmetry is like right there. If I folded the left side onto the right side, it would be perfectly symmetrical. So here's a hint. Your axis of symmetry always goes through your vertex because your vertex is the highest or the lowest point. So your axis of symmetry always goes through the vertex. There is a formula to figure out how to calculate this axis of symmetry. Here's the formula. X equals negative b over 2a. So the formula is x equals negative b over 2a. You don't have to memorize it. It's on your star chart, quadratic equation, axis of symmetry, negative b over 2a. All right, so it's right there. So you don't have to memorize it, but you do need to know how to use it. Okay, so let's take a look at this picture. You see how in this picture I have a parabola, okay? My parabola, the vertex is right here, right? It's the lowest point. The axis of symmetry is this one right here. If I were to fold on this orange line, the left side would match up with the right side, okay? For this one, I would say the axis of symmetry is x equals 0, right? Because a straight up and down line is not y, it's x. Like, remember when you name lines, it's always the opposite letter. So you would think this is a y equals because it's vertical, because it's like the y-axis, but you always have to flip it. It's actually x equals. So what does x equal? This imaginary number, which is 0. Okay. Any questions so far? All right, let me teach you how to graph this then, okay? So go to the third side, which is the second paper. So if you're online, it's going to be the third paper, but if you're in person or if you printed it out, it's like it's the one that says extra practice with a bunch of blank grids. Okay, so we're going to practice graphing, okay? But the first thing we're going to do before that is we're going to practice our vocab, okay? So in exercises 1 and 2, identify the characteristics of the quadratic function and its graph. So when I say characteristics, I mean, what is the vertex? So let's write this on the side because these are all questions I need to know how to do. What is the AOS? Remember, AOS means axis of symmetry. What is the domain? Oh, it's been a while since I've talked about domain. And if we talk about domain, we always have to talk about, what is the other? Yeah, range. And is this a max or a min? Okay, so these are all new vocabulary things that we need to know about this picture. Okay, so let's answer it. The vertex. The vertex is the highest or lowest point. So your vertex is right here. Can someone in person raise their hand and tell us what, comma, what? Where is this vertex in this graph? Read. So my vertex is at -1, +1. Okay. My axis of symmetry is that imaginary line where I fold it, it goes like, it's symmetrical, right? Remember how I said it always goes through the vertex? So you know the imaginary line has to be right here. Does somebody online think they know where is the axis of symmetry? At what number does it go through? Ryan? Okay, so it goes through -1. So here, and this is the biggest mistake that everyone always makes, even like at the end of the chapter, you always forget to do this. So axis symmetry is not just a number, right? This is a line. So we have to name this line. Yes, it is -1, but like this line, is it an x equals or is it a y equals? X, okay. Remember, you would think, oh, it's a Y because it looks like the Y axis. But when we name lines, it's always the opposite. So everyone always forgets the axis symmetry is not just a number, it's the line. X equals, and then that number. Okay, domain. So remember how we do domain? We say, okay, so domain is X. You always draw your alligators eating to the right. So domain is X, like left and right. So how far to the left do you go? Infinity. How far do you right do you go? Infinity. So if we have infinity on both sides, what do I actually write? All real numbers. Guys, the domain 99.9% of the time is going to be all real numbers for parabolas, right? Because you always have arrows, unless you have a word problem where like it stops somewhere. But it's all real numbers because it goes all the way to the left, it goes all the way to the right. So when you have infinities both ways, then it's all real numbers. Okay, range is not going to be all real numbers. So range, you have your y, your alligators always e to the right. Okay, range is y. Y is up and down. How far low does your picture go? 1, right? Do you see how it starts right here? So it starts at the 1, and then where does it shoot off to? Infinity. So remember, if you have infinity on just one of the sides, you just erase the side that has infinity. So your range is y is greater than or equal to 1. And you can reverse it if you want to. You can just write y is greater than or equal to 1. Okay, max min just means look at this vertex. Do you think that this vertex is a maximum or a minimum point on this picture? Minimum, right? Because minimum, it's the lowest one. If it were maximum, this would be the highest point. So this picture would give you a minimum point. And so these are all vocab words that you need to know how to identify in a picture, okay? So online kids, you are up for number 2. We have to figure out the vertex, the AOS, the domain, the range, and then the max min. We have to answer all those questions. All right, here we go. Somebody online, will you type or will you unmute yourself and tell us where is the vertex? What, comma, what? 3, 3 is so close. It's kind of small, sorry.
3 comma.
Yeah, 3 comma 4. Do you see how it's right here? So close. 3 comma 4. Okay. AOS. Does someone online think they know the AOS?
3.
Yes. So remember how we just said it is the number 3, but it's not a number, it's a line. So something equals 3.
X equals
Yes,
3.
it's the line X equals. It's not Y equals because it's always reversed, that letter. Okay, domain. Somebody online, what do we think?
All real numbers.
It's all real numbers. The reason why is because you go all the way to the left, so negative infinity, all the way to the right, positive infinity. So when you have infinities on both sides, you write all real numbers. Okay, somebody different online. The range, what do we think?
Is it 4 and then infinity?
Okay, so if I'm going to set it up like this, y and then my alligators e to the right. So what number would I write first? Negative infinity, right? Because it's y is up and down. So how far low do you go with the smallest number, negative infinity? How high do you go? Positive 4. So it is 4 at infinity, but I need to make sure that you put it in like the right spot because we would have to erase the side that has infinity. So it's just y is less than or equal to 4. Like, do you see in this picture, y is going down, so it's less than? Well, what is the picture less than? It's less than the 4. Everything is less than 4. That's why it's y is less than or equal to 4. Okay, somebody that has not spoken yet online, does this picture have a maximum point or a minimum point? Look at the vertex.
Max.
Yes, because you see how up here it's the highest, so it's a max. Okay, so now that we know how to identify all these things, let's practice graphing them now. So here's the thing, guys. If I wanted to graph this, I could easily just go to my y equals, type in my equation, 5x squared, boom. Oh, well, super zoomed in, but I can do this, then I can go to my table, and I can do that, and then I'm done. But that takes a lot of time. You might be like, wait, that didn't take that much time. Well, if I show you how to graph it by hand, you'll see that it takes like half of it, like you save probably half your time. Okay, so first thing I want you to do is go ahead and draw your X and Y axis, and let's graph this. Okay, so it says to compare the graph of f of x equals x squared. That's your parent function. That's where you always start off with. So if you just have f of x equals x squared, that's your base. So your base always has a dot at the origin. And you see how x squared is 1x squared? So 1x squared means over 1, up 1, over 1, up 1, boom. This is a picture of y equals 1x squared. That's your parent function. But they're not asking me to graph that. Well, they are, but they're asking me to also graph y equals 5x squared. So if I have y equals 5x squared, you see how I'm going to go over 1 and up 5 because it's 5x squared. So over 1, up 5. 1, 2, 3, 4, 5. Over 1 and up 5. 1, 2, 3, 4, 5. So do you see how that is my picture of 5x squared? So look at how quick that took me to graph, right? I didn't have to put it in my calculator, go to the table, look at the points, plot the points. I mean, I could, but graphing it by hand is so much quicker. Now it says compare them. So what do I compare about them? Because they look different. So what can I say about them? I can say that, do you see how like, imagine me like taking like these little arrows and putting them in my fingers. Do you see how that from the black one to the orange one, doesn't it look like I took the black one and I pulled it up and I stretched it to make it skinnier to make the orange one? Do you guys kind of see that? So like if I took this and I pulled it up to make it skinnier to make the orange, then what I did was I had a vertical stretch of 5. I stretched it by a factor of 5 because it went from 1x squared to 5x squared. So that's one thing that whenever I compare it, you have to say, is it a stretch or a shrink? In this case, it was a stretch because I pulled it up. Okay, the second thing is, let's talk about their openings. Do you see how both of these arrows, the parabolas, they both open up? So I can say both open up. And then the last thing I can talk about is their AOS, the axis of symmetry. For their axis of symmetry, do you see how it's the same for both of them? The axis of symmetry was y equals 0 for the black one, and it's also y equals 0 for the orange one. So AOS is y equals 0 for both. So that's me comparing this picture. So you're going to have to learn how to do that as well in your video notes. So let's take a look at number 4. So number 4, go ahead and draw yourself an XY axis and then graph your 1x squared. So 1x squared means center at 0, 0, up 1 over 1, up 1 over 1. This is 1x squared. But now instead of 1x squared, I have negative 4x squared. So I still start at 0, 0, but I'm going, do you think I'm going up or down now? Down, because it's negative. How many am I going down? 4. So over 1, down 4, over 1, down 4. Here is my new picture of negative 4x squared. So it's a little bit skinnier. And it's going down because it's a negative now. And it's going down 4 because it's 4x squared. Okay, so now let's compare. I went from here, I still made it skinnier. So even though it's facing in the opposite direction, you see how I still made it skinnier? So if I still made it skinnier, then it's still a vertical stretch of, and then 4. Or you can say negative 4. The negative doesn't tell you anything about the stretching or shrinking. It just tells you if your picture goes up or down. Okay, the next thing we talked about was the opening, right? Both of these opened up. Do both of these open up? No, the orange one opens down, right? Doesn't that open down? So I can say the orange one is m of x. So I would say m of x opens down. Okay, the next thing we talked about was the AOS. It was the same for both of them here. Is it still the same for both of them here? Yeah, right. Your AOS is still at this thing. So I would say AOS is, what is the AOS? Y equals 0 for both. Okay, but we didn't mention the biggest difference. The biggest difference is one's going up and one's going down. Yes, Ryan? Oh, yeah. So this one had a min and this one had a max, right? So in other words, I could say that there was a reflection over the x-axis. So if there's a reflection, right, if it flipped, then we have to say that there is a reflection. Okay, 2 more. So first thing, I have a new formula, but let's draw our parent function. Our parent function is at 0, 0, up 1 over 1, up 1 over 1. Go ahead, Reed. Okay, so this one's kind of tricky now because, okay, it's negative. So if it's negative, does it go up or down? Down. But it goes down how many? Not 1. 1/5. Like, okay, so like for this one, it went down 4. So it went down 4 whole like squares. This one goes down 1/5 of a square. So this is what you kind of have to think to yourself. Like you're going over 1, but you're going down 1/5 of a square. So imagine taking this square and breaking it into 5 parts, like a fraction, 1/5. So you're only going down 1/5 of a square, which is hardly anything at all. And then this is your picture. Does that make sense why I have to like make a fraction in my grid? Because it's 1/5. I'm going down 1/5 of a square. Okay, so I took this. Did I get fatter or skinnier? Fatter. So doesn't it, instead of like pulling it up to make it skinnier, doesn't it seem like I like smushed it down to make it fatter? Does that kind of make sense? So instead of this being a vertical shrink, or sorry, stretch, because I didn't stretch it out to make it skinnier, I shrunk it. So it's a vertical shrink. That's how I got it fatter. I shrunk it down. I flattened it to make it fatter. So it's a vertical shrink of 1/5. Oh, Melanie, can you give it to her? Thank you. Okay, so it's a vertical shrink of 1/5. And basically, if you know if it's a stretch or a shrink, it's a stretch because it's bigger than 1. It's a stretch because it's bigger than 1. Don't look at the negative, like the digit. The digit is bigger than 1. It's a shrink because it's less than 1. Don't look at the negative, just look at the digit. Yeah, Ryan?
Why isn't it over 5 and down 1?
Good question. Why is it not over 5 and down 1? Because so a lot of kids think this way every year. 1, 2, 3, 4, 5. So why isn't it like this? Because it's not rise over run. Don't think of it as your slope. So if I were to put this in my graphing calculator, I'll show you. Okay, so negative 1/5 x squared, because I could just plot this in my graphing calculator. If it were over 5 and down 1, it would be 5 comma negative 1, right? And do you see how it's not 5 comma negative 1 as a point? So don't think of it as slope. And you're so used to thinking of it that way because, well, you did like slope and linear for a very, very long time. Okay, so it's a vertical shrink of 1/5. The second thing we talk about is the openings, right? We always talk about the openings. So what should I say about the openings? What about it? N of x what? Opens down. Because they don't both open up. So N of x opens down. The next thing we talk about is the AOS. Is the AOS still the same for both of them? Yes. So I would say AOS is, what is the AOS? Y equals 0. Thank you for saying the line, not just the number. Oops, or both. And then the last thing we would talk about is if there was a reflection, we have to write there was a reflection. Was there a reflection? Yes, because I flipped it, right? It went from going up to going down. So I would say reflection over x-axis. Okay. The last one, do you see how there's a parentheses here? Like around the number and the x? There is no parentheses here. There is no parentheses here. There is no parentheses here. So this one looks completely different. So some of you might be like, this is a vertical stretch. This is a vertical stretch. This is a vertical shrink. Yes, Ryan? Yes. So first of all, this is whenever you see a parentheses in your problem, because they're like, well, when is it going to be a horizontal? And so whenever you see parentheses, it's going to be a horizontal shrink or stretch. And then Ryan was saying, isn't this 3/5? Yeah, looking at it as a fraction is much easier than looking at it as a decimal, but I'm not going to get into this problem because it's a little bit too complicated. I'll let Ms. Peterson talk about it in the video notes, and then we'll talk about it more on Tuesday. Okay, so let's just skip this for now. The biggest thing I need you guys to know is how to identify these things. If you can do that, you're good. And also how to graph it by hand. So there's graph paper for all of your video notes, either on Schoology or on the blue counter. All right, and that is it for